everyone. Welcome back. Let's keep doing the problem solving for the thermochemistry. For for this question, we know the standard enthalpy of the formation of the ammonium is negative 46.1 kilojoule per mole. Okay, and we're looking for the enthalpy of this reaction. Okay, so it's actually you're looking for what is the enthalpy of this reaction. Okay, we're looking for this. Well, actually, for this question, there's a two-way to solve this question. So let's talk about the first part, first way. Okay, for the first way, well, you need to think about, okay, so what is the standard enthalpy of formation? What is the standard enthalpy of formation? Okay, so here we know the standard enthalpy of formation of the ammonium is negative 46.1 kilojoule per mole. Okay, then you need to think about what is the standard enthalpy formation. Last time we talked about actually if we enthalpy of the formation, actually there's the equation associated with. Okay, and this equation is a specific equation to form the ammonium. Okay, so remember yourself to form to make write the correct equation for the enthalpy of formation of ammonia, and then when you think about it, we produce is a form 1 mole of the ammonia. Okay, and then the reactant must be the pure elements. So this is ammonium plus the hydrogen. The third requirement is those pure elements should be at the most stable form. As the nitrogen, the most stable form is the nitrogen gas. Okay. For hydrogen, the most stable form is hydrogen gas. Okay. So then we need to balance this equation. We have one nitrogen on the right, so we only have one nitrogen on the left. Okay, we have 3 hydrogen on the right, so we should have 3/2 the hydrogen on in front of the hydrogen gas. Okay, and then we check. So we have 1 nitrogen and 3 hydrogen on the left and 1 hydrogen and 3 hydrogen on the right. Okay, so this equation can be represented as the equation, and this equation, the enthalpy of the reaction of this equation, we can assume this as the enthalpy of formation. Okay, so enthalpy of formation of ammonia. Okay, and we know this is a negative 46.1 kilojoule per mole. Okay, yeah, and then look at the target equation. Okay, look at the target equation. Is there looks familiar? Right, right. Those two equation looks pretty familiar. What that mean? Actually, if I can rearrange this enthalpy of formation equation, we can get the target equation, right? So first, what we do, we reverse the enthalpy of formation, this equation, okay, and make like a nitrogen gas. This is nitrogen gas. Nitrogen gas equal to 1/2 nitrogen gas, the ammonia gas, plus 3/2 hydrogen gas, right? And this, once we reverse this equation, remember what happened. The enthalpy of this, standard enthalpy of this equation, gonna reverse the sign, which is become 46.1 kilojoule per mole, right? Okay, and then once we have this, we look at this target equation. The target equation have a 2 in front of the ammonium, 1 in front of the hydrogen, and the 3 in front of hydrogen. 3 in front of hydrogen, 1 in front of nitrogen. You see, is the if we time 2 on this target equation, on this equation, we can get the target equation, right? So this we are going to time 2 for this equation to get 2 ammonium gas equal to ammonia, nitrogen gas plus 3 hydrogen gas. Okay, so if we time 2 on the equation, the enthalpy of the reaction also need time 2, which is 2 times 46.1 kilojoule per mole. And then we will get 92.2 kilojoule per mole, right? And the 92.2 kilojoule per mole is the right answer for the enthalpy, standard enthalpy of these reactions. Okay, this is target reaction, right? Okay, so we actually at the very beginning we talked about for this equation, if we want to solve this equation, the enthalpy of the reaction for this equation, there's a two-way to solve this. This is the one way we solve. Let's do the second way to solve this problem. Okay, second way is, did you remember we talk about the enthalpy, the standard enthalpy of the reaction can be the sum of the enthalpy of formation of the product minus the sum of the change of enthalpy of formation of the reactant, right? So we can use, we can also solve the problem. The problem is, okay, this equation, the equation is like that, plus 3 of the hydrogen gas. Okay, so the sum of the enthalpy of the product, okay, we can do the enthalpy of this reaction can be right like the sum of the enthalpy of a product, which is the enthalpy formation of the nitrogen gas plus the enthalpy formation of the hydrogen gas times 3, right? And minus the enthalpy formation of ammonia gas times 2, okay? The reason we times 2 because we have a 2 here. The reason times 3 we have a 3 here, okay? Yeah. So, and also we talk about as long as is the elements and in their most stable form is 0. The enthalpy of formation is 0. So the enthalpy of formation of a nitrogen gas is 0. It's 0 kilojoule per mole. And the enthalpy of formation of the hydrogen gas is the most stable form for the hydrogen. So this one is also 0 kilojoule per mole. When we times 3, then we minus the enthalpy of formation of ammonia we already have, which is a negative 46.1. 46.1. Then make sure it's right? 40 negative 46.1. Okay, so negative 46.1 kilojoule per mole times 2. Okay, so here that's gonna be 0, and we minus So the negative 46.1 times 2, and the answer is going to be 92.2 kilojoule per mole, right? So the enthalpy of this reaction, the standard enthalpy of this reaction is the same, 92.2 kilojoule per mole, right? This is the second part. I hope you got it right. Okay, yeah, I'm glad you watch it and see you later.